toggle the screen. There we go. Hello, welcome. I see we have 4 attendees so far. Oh, well, we're up to 9. We'll get started in just about 1 minute, just as people come in. Thanks so much for joining us today. Wonderful, welcome. Okay, I'm going to go ahead and get started. Hello, everyone, and welcome to the Green Grid's introduction to the Data Center Resource Efficiency Metric webinar. We will be introducing both the metric and the scoring calculator today. I just want to thank everyone who has taken the time to join us today. Just a note, your microphones will be muted throughout the presentation as we're only taking questions in writing. Please type any questions you have in the Q&A function at the bottom of your screen at any time during this presentation. For any technical or logistical questions, we will reply back via a private message. We will answer all content-related questions verbally towards the end of the webinar. The recording will be posted in the public library after the webinar at thegreengrid.org. Let's move on to introductions. My name is Rebecca Rafferty, and I'm the Technical Program Manager at the Green Grid. With us today, we have Valerie Diehaus, the General Manager of the Green Grid. Thanks for waving, Valerie. And Julius Neudorfer, Chair of the DCRE Workgroup, who will be presenting. Thanks so much. And with that, I'll hand it over to Julius. I'll put a reminder in the chat about the logistics.
Okay,
thanks.
thank you very much, and welcome. We're going to cover the Data Center Resource Effectiveness Metric, and we also have a companion piece called the Scoring Calculator, DCRE Scoring Calculator. And let me get started, and we'll take you through it. If you have any questions, as Rebecca said, please get them into our Q&A session, and we'll try to answer them at the end of the program. So a little bit of quick history about the Green Grid. Basically, it's been around since 2007 and it's put out a lot of information, metrics, white papers, etc. And of course, it's well known throughout the data center world, and I don't need to over elaborate this, but it's done a lot of good work. I think a lot of data centers and industries follow the work of TGG, and it set the bar when 2007 got everybody aware of, obviously, use of power effectiveness. Since then, of course, there's been great developments, including water usage effectiveness, carbon usage effectiveness, the use of energy reuse, and energy reuse factors. Now, these two seem alike, but one refers to energy reuse inside the facility, one external to the facility. In other words, recovering energy for external purposes. Now, little bit of factoid here. Although TGG put all these metrics together, in 2016, TG transferred that ownership over to ISO, and it's now part of the ISO IEC 30134 series. So there's still continuing work between ISO and TGG, but just to be clear, ISO is right now taking care of these under the names PUE, WE, etc. in that series. So going forward, of course, we are using the name PUE as a reference, and water consumption with the acronym WE as a reference to the history and also the ongoing. But what we've done now is rethought the way things are put together and how they should function moving forward. And so we're going to continue to use those as a, as an acronym just for reference, but understand the metric is its own TGG work. So what we've done now is looked at something that we feel is very important, very timely. It's always been a problem, but with everything going on in the world, both, climate change, et cetera, water stress has become an important issue both for operation of industrial processes as well as human existence, more importantly. So we've come up with something called water usage impact. And basically, it's a proxy for looking at the amount of water that is available in the area, hence the name water stress, and the amount of water for data centers that are pulling from that water source, whether it's an aquifer, whether it's a municipal plant, et cetera, potable water. And so this is going to be, an important thing, and it always has, but now we're sort of calling everyone's attention to it. And the other thing that affects the effectiveness of use of energy and resources like water, and they're closely tied together, is climate zone. And so now we're trying to do all the things that PUE did in a simplistic form, but it really was a one-dimensional metric. And nothing has changed. It's still a very valid metric. It is a ratio of the energy that's coming into the building versus the ratio that's being used by the IT load. Here, we're trying to put things in context to sort of give you a more holistic picture. So the developments of this has been actually quite long. We've had quite a number of people involved in this. A lot of the major players that were participating in this, including the hyperscalers such as Microsoft, AWS, et cetera, the chip makers, AMD, IBM, and NVIDIA more recently. So plenty of people are involved in this metric. So in trying to put this together, PUE was one of the things that set the simplicity bar and sort of told us that we have to keep this simple and easy to understand. So we looked at this. There's a lot of things going on in this metric, and we said one of the things we have to make sure that we make this clear, and that's explained in the white paper as best we can in many different aspects of this. We're going to try to cover that. Objectivity. This is meant to basically be neutral for any situation. There's nothing here that is trying to slant the scale one way or the other. So objectivity is very important, both to our members and hopefully to our users of the metric. We want it to be simple to implement and be low cost. It is, in fact, the metric is free. And we've also included the scoring tool, which was also free for distribution for non-commercial purposes. That is to say, you can't resell it. And of course, that's subject to the terms of use of any TGG material. Now, of course, a lot of this is based on existing information that a data center will have. We're talking about water usage. Now, water usage is easily obtainable because if you're buying it from a municipality, you're getting billed by the gallon. And if you're actually pulling something from an atmosphere, your BMS system should be able to tell the flow rates and so forth. So we're not looking to cause this to be expensive to understand or use in any way, shape, or form. What we hope to accomplish is this is a multi-purpose tool. It can be used as a modeling tool because you can simply select in the tool, and we'll cover that in a moment, what you're doing now, what you may want to do, and see the impact on the scoring mechanism. And we'll show that to you shortly. And ultimately, we want to raise awareness. In other words, if you're starting to think about what we put into this tool and what you use when you start putting some numbers in, we hope that this will be a guideline, just as PUE got everybody aware of their energy effectiveness. We hope that this tool is going to raise overall awareness of how water is used and other resources. So here's the big picture. We had this beautiful design 2 years ago almost. And we said, we're going to put all of this together, and in 6 months, we'll have a metric that covers everything we could think of and then some. Well, to be honest with you, we realized that this got a little more complex the more we tried to be accurate in our information and how we looked at things. It got a little bit fuzzier than we hoped. So we started off with PUE, and then we went to water. Now, I just want to point something out. In this diagram, we have WUE. The original WUE actually had two components, WUE site and WUE source. What we did here is we separated them. So for purposes of this tool at this point, right now, we're only talking about WE site because we come back to WE source as the last portion of the metric. From there, water stress now creates this water usage impact. That's our new component, and it's also going to turn into a standalone metric. Climate zone is well understood. That information is all public. You can get it from ASHRAE, and that becomes another factor. And finally, at the last, we look at water consumption at the energy source. So that's where this metric is today. This is version 1 of the metric that we're releasing last month, and as well as the metric scoring tool. Over here, this is what we're continuing to work on. So this is in the plan, but we found that the more we dug into these factors and make them interrelatable to the way the metric is here, we needed more time to do that. So rather than delay the project any further, we decided to issue this as version 1 while we continue to work on version 2. What's more interesting, little notice it's a different color. So everything that we have here is the physical data center. And that's what every metric's been written around, the physical data center, the cooling, the electrical losses, and now we're bringing in this climate zone factor, etc. But in the end, what we have is a big box with a bunch of stuff in it, and everything is just based on delivering the power to the stuff. All right, chips, power supplies, servers, you name it, network equipment. And so we decided that in the end, what good is this if we don't know what we're building? We can't count the widgets, but in a way we can. CERT has been doing this for a while. All right, so CERT looks at the performance levels of equipment, such as servers, obviously, network equipment, etc., different versions of different metrics going there. And ultimately, TGG is working on the IT work capacity metric, which says the actual usable function of what's being done in relation to the power being drawn. This is a complete subcommittee working quite tirelessly on a very complex project. This has been the holy grail for everybody way before we took this on. And we have a concerted effort now by some very dedicated people who are looking at just this project. We'll touch on this at the end, but just wanted to make you aware of the importance of how we're looking at this for the future as it gets developed. So getting back to the heart of the metric as it stands now in version 1, we literally are looking at the most basic thing. We call it level 0, which is effectively what PUE is as it's presently calculated. All right, each one continues to move across as we work through it. So in level 0, it is simply essentially PUE. Now we notice we just keeping it as the acronym PUE. We're calling it facility energy effectiveness. When we move to level 2, we start incorporating water usage as a factor to be combined with just the basic facility energy. When we move to level 2, we now sort of incorporate water usage effectiveness with water stress, and then it becomes water usage impact. And you'll see that as well when we demonstrate it. In level 3, it continues to use water usage impact, and now we add climate zone. And in level 4, we now have all the factors that we started with across the board, from the basic use of energy, and in the facility, of course, to the water impact of water withdrawn, climate zones, and ultimately the amount of water being used by a power plant. And this is probably the one you'll see why we left for last, because not everyone is able to get that information, but we wanted to separate so it's usable at any level. So here's a screenshot of the tool itself. It's a separate item, and we'll tell you how to get hold of this a little later in the program. But this is a constantly variable input here. So everything here is, you can enter numbers, some are drop downs, and as you enter them, they begin to impact the score as we go along. And we'll show you how that works. So we're doing it 2 ways. The old DCRE method, we're using the percentile, right, which was the old DCIE, I should say, is really the inversion of the number, which we call PUE. PUE became the more popular format, so we're sticking to PUE style so people can recognize it. And as you see here, we've entered 1.2 as a PUE equivalent. And of course, because there's no other factors, we wind up with a PUE of 1.2, or I should say a level 0 of DCRE 1.20. All right, so when we look at this, we want that consistency. We believe that part of getting this metric absorbed and understandable is to have a different scoring structure. So this, we hope, is going to make this more easily to understand. Anybody who can put their their PUE number equivalent, you understand that you're looking at where you were, and that's why we're calling it level 0. And as we move through this, you'll see how these all play out. So that's level 0. In level 1, as we saw before, we now have water usage the way we describe it in general, the amount of water versus that. Now, what happens here, and we'll show this to you a little bit in the next slide, we begin to reduce the weight of the energy alone as we keep adding this. And in level 2, we now transferred ourselves to the water usage impact. These are no longer calculated. The sum of these have been calculated in here. We'll show you how that works. At level 3, we simply have added climate zone as it carries through to level 4. And finally, at level 4, we are looking at the amount of water from the energy source, if you can find it. If you can't, well, there's ways to estimate it, but right now we're just saying you need to obviously do that if you want to report this. And I must stress that this is all voluntary. There's nothing forcing you to do anything, publicly or internally. We hope internally that these things will begin to be looked at so that people can see what the impact of every value that changes here. So the weight changes, as I mentioned before, and as we progress away from level 0. So all of these must add up to 100%. So when I look at it here, my weight here is 100% because it's just that. It's the only factor in there. When I look over here, now I've reduced the 100% value of the facility energy down to 80% because 20% is now given to weight-wise to the use of water directly. Once I get to level 2, now my weight has not been reduced because it's the same. Whoops. As you can see here, 20% here and 20% here is carried through. At level 3, we've now kicked in another 5% for climate zone, so my energy weight is down to 75%. And finally, the energy weight alone is worth only 70% because I've added the source water. So this is really the heart of the metric, is this balance of reducing the relative values of them to show that energy alone is not the only thing that's going to play out in this thing. And depending on how you put those numbers in, you'll find that you can actually have a lower number than just the energy number, depending on how much resources you're using. If you're in a stress region, it's going to have a negative impact. If you use 0 water or very little water, it's actually going to have a better score as you go along. So we tried to balance this out. A lot of people looked at this for a lot of months while we went through this. I can assure you, a lot. I see Valerie smiling because she's so. In any event, so continuing on, we look at the fact that water usage is straightforward. It's liters per kilowatt hour by T energy. And the factors we have brought into here range from 0 to 2 with an assigned weight on the 20%. So if you start reducing this right now, this is a static shot. I'll try to show you the tool in a little bit. So if I change these, they will impact the remaining scores. And remember, the existing WE standard is only applied in level 1. And as we move through this, of course, it's going to continue to run through the sequence, and I'll show you that in a little bit. So water stress factor, which I think is one of the most important things that we really looked at, is this relationship behind the real impact on the community that you're in. And it also is not just a community social issue, it's a practical issue, both from an operating data center's point of view, as well as a planning point of view. As you know, data center demand for energy has gone way, way up. And if you're using water as a means to reduce your energy because you're using evaporation or any other technique that you want to call adiabatic cooling, direct evaporation, you name it, there's so many variations on that. The relationship now becomes if you're using a lot of water in the area that doesn't have it, you may not be able to build there. You normally find this out very late in the process when you're applying for permits in the planning board stages, local resistance because they don't have enough water, and also the possibility that we may have water today, but with the way weather's been, maybe we won't have that much water tomorrow. So you have to start looking in a design fashion to see what the impact of a high water usage is in relation to the water stress of the area. And this is true globally. It's not just a US thing or a European thing, it's a global problem. So this geographic information, we said, well, TGG could go around the world and try to get this information. And we figured we were having enough trouble just doing it by ourselves to get this metric going. So we looked around for sources, and WRI is a internationally recognized source. So we're pointing back to WR ratings in our water stress metric over here, the water stress factor that creates our water usage impact metric. And for the moment, we're only keeping this simple by talking about potable water. Yes, there's reclaimed water. Yes, there are variations on that. But in this first version of this tool, we are trying to keep it to potable water that's being withdrawn from the atmosphere or from a water plant that's used for human consumption. So this is really one of our, sort of our key points in this metric. And it's probably the one that's going to be the most controversial, but we figured that we would put it out here and certainly try to explain it to everyone. So here, as you can see, that this has been transferred from the 20% number here over here, and then these all go to zero. They're taken out of the equation at that point. So above level 2, essentially WUI is the ruling component in here. So again, just to show you, it transfers all across all 3 levels at that point. 2, 3, and 4 now are based on a 20% weighting, but the score that it affects is really going to be based on the number that you put in for your water usage and the water stress. This becomes a calculated number. You can't enter it. It becomes the calculated value. So what's happening here? Right now, we're using 1 liter per kilowatt hour. That's the entry value here. But you're in a stress, zero stress area. Yet you're pulling this water, so you do have an impact statement here. So this is kind of important to note that even if you're in an unstressed area, your amount of water that you use for WE is still being carried through, and it's going to impact your score. How much is being done by the climate zone is not yet into play, but as we go forward, if you're doing it in a climate zone that's difficult to cool, you'll see that it actually went down from 1.2 to 1.19, and we'll play with that in a little bit. So as I said, WUI right now is baked into this. We are going to be issuing it later this year in terms of a standalone metric. So climate zone, as I said, is relatively well known. Its impact is relatively well known in terms of the amount of water being done in a very hot, dry climate is versus a area where climate is cold or cold and wet. All these things come into the ASHRAE climate zones, and we are pointing back to the ASHRAE climate zones. So straightforward enough. It's got a 5% weighting factor. It still will, of course, inherently impact how much water usage because they're tied together, whether we create it in a metric or not. So we try to accommodate that because a lot of this is already reflected in the amount of water that you're using inherently. And 1 being the hardest to cool and 7 is the easiest, which why you can see when we set this at 1, your score actually improved over the straightforward level 1. We're using a lot of water in level 1, but because we're doing it in a climate zone that's very hard to cool, it actually shows a positive benefit as opposed to just calculating it here, where we got a score of 1.3, then we neutralized it out here, and then we, of course, went here. So next stage is water source at the energy source. Now, this has been around for a very long time. It was in the original TGG metric, as we talked about in the first slide. So the problem with this is that where is your power coming from? With the age of power purchase agreements and how things are done, you don't really always know what your disclosure is. Now, certain areas have power plant information if you choose to get it. How that's interpreted is beyond the scope of this, but the answer is it is obtainable from your power source if in fact you have a direct access to that information. We put this off for last because we feel that rather than have anybody be forced to consider this at every level, that this is the one that is most difficult to obtain, especially when there's purchase power, which is also one of the reasons we deferred waiting for purchase power to be handled in the future version of metric. But we feel there's enough core principles in this tool to say whether you're disclosing at level 1, 2, 3, or even 4, if you can find this information, it should be a guidepost for everyone's look towards what is my data center impact to the community, what is the possibility of functioning in an environment that's water short, and therefore we can't change what the power plant is going to do because that's a decision that was made long ago and outside the scope of the data center. But now data centers are even thinking about having their own power generation sources. So you can see how that could be a real factor. Idea is it's baked into the tool. So frankly, as you can see, it's voluntary. There's no recording requirements. There's no one to report to. You don't report back to TGG. The answer is, like PUE, it became, in some senses, a comparison tool for perhaps marketing. Some zones have used PUE as something to be a regulatory type number or requirement. We're not putting this out as a regulatory item. We're putting this out as a voluntary one. So you can choose to self-evaluate this using these tools. And also, you may or may not want to disclose it. You may want to think of that as an internal corporate target. You may want to see, am I going to design a data center that's now going to be more water efficient? And where am I going to locate it? That's what we hope both the white paper and the tool are going to simply make it more practical to do this in a very cost-efficient manner. You can learn to use the tool in a matter of an hour. You can read the white paper, and see it, and then try for yourself what this is going to do. All right, so who's going to use this and what is the benefit? Everybody wants to know what's the benefit. Well, it allows you to do internal evaluations. If you never reveal anything and you have a corporate meeting, you go, wow, some of our sites are very good and some of them are not so great. Well, then that changes everything, right? So that's one of the things that happens. And of course, you can model your score at any level and project the changes. So if you're using 1 liter per hour, per kilowatt hour, and you can bring it down to 0.7 or 0.5 just by changing the performance characteristics of your cooling plant. That's optimization. No modeling there, or you're modeling the change, I should say, but you really still have the existing design. But on the other hand, if you know you have a choice between building a cooling plant that revolves around evaporation as opposed to simply no using water at all, well, then that becomes a planning tool. So what does that mean to us? You can optimize, as I said, take the existing plant and see what you can do to optimize it. Or if you're deciding, making some decisions, you can trade off. What happens when you site water usage is low versus energy efficiency being poor because you have less cooling effectiveness on your cooling plant? And what is the impact on water usage? So these are the trade-offs both for practical purposes, for modeling purposes. There's a lot of ways to look at this, and you have to play with the tool to see the trade-offs happen. And what about cost justification? People will cost justify something if your energy is reduced because you're using a lot of water and water is cheap. Well, people might just decide to say, well, we're a business. All we really want to do is reduce our operating costs. But as water becomes more scarce, it also becomes more expensive, and it may not even be available, which is the trade-off. So you have to plan to say, well, suppose, for instance, that right now I can afford to use a lot of water, but later we have to be prepared to dial it back because if our energy prices start to fluctuate, maybe we can put this into our long-term plan. Again, it can be used for any number of those trade-off purposes. So finally, this is where we really want to start talking about what really happens and why we put that building up in the first place, is this thing we called IT. So what is it? I just took a sample of a rack that's, let's say, been around for a few years. But I did this a while ago, this picture. In any event, let's see what we're talking about here. What does that one do? The one is the energy going into our compute. 40 kilowatts is an interesting number, because if I was able to take some Weber barbecue grills and put them in the same size rack, they would be equivalent to about 40 kilowatts of heat. 27,000 BTUs for a little small size Weber grill comes back to round numbers around 40 kilowatts. What can I do with that? Well, from personal experience, I can tell you over a period of time, I can get 4,000 hamburgers done or 6,000 sausages. Now, I've never tried to do 10,000 shrimp, but I think somebody in Australia probably did. So, the reality is it's just heat. And that's what we're doing, is we are heating up a building using energy, hopefully to do something useful. Now, I'm a New York guy, so a lot of pizza can be made in 40 kilowatts inside of a rack. It's very convenient during a party. But the real question really is, what are we doing with this 40 kilowatt rack? And what we hope is happening is that we're doing web pages, searches, gigabytes of reading, I/O, stored information, calculations, permutations, and dare we say it, AI. All right, so what happens then? This is the whole reason we built the building, the whole reason we're pulling power, the whole reason we're evaporating water. And that is the basis of the IT workload metric. All right, this is really the holy grail of trying to put this whole picture together. Everything else before this last slide was about the building. So from this perspective, this is where the long-term vision is here. And we're going to incorporate everything over here, which is part of the physical infrastructure, but this is on its own track. This in itself is valuable. So whenever this is finished, it's fine. But right now, if this comes out, this is what everyone's been waiting for in terms of the deliverables. What is my deliverable? I'm doing some form of work in computing format. And that looks at the processing of the hardware, right? The storage and the networking, but it's also the software. The software itself can be highly efficient or it can be very inefficient. The question is, when I put all this together, the software is dependent on the efficiency, the raw efficiency of processors. So CERT takes care of that. CERT looks at what a server is doing and compares it to its energy usage to do a task. And that's already well within the purview of TGG. So they're already doing this, but now the real question is, how do we combine all this? And as I said, this is a work group that's been working diligently on this project, and we hope to be able to tie this into this grand vision that we have for not just physical effectiveness, but ultimately that we now have a payload that's also operating efficiently. So from that point of view, essentially, the whole framework from beginning to end is to look at the entire holistic picture. It's meant to be a guidepost. It's meant to be a tool to help you shape your direction and also to optimize what you have. And should you choose to disclose it, you're already disclosing PUE in most cases. And so switching over to level 0 is a no cost. It's the same number. We hope that you already are aware of your water usage, even if you don't look at your stress level. So moving into level 2 would be an easy choice. And I would hope that people would even use the level 2 if they are not ready to jump into the stress factor. They may not know their stress factor. They may have to look it up. So there's reasons that, corporate personal reasons, or not personal, but reasons that you would sort of take your time moving into this. And we hope that the more people adapt to this, the more people will begin to use it and disclose it. And we hope that that's going to be as successful as PUE. People say PUE is obsolete. It's not obsolete. It has never changed. It's still a valid number of the physical electrical performance of the building. So TGG has been doing this for a while. As I said, it's 2007 and now we're in 2015. I have to take off my shoes and socks to figure that out, but it's almost 20 years minus a couple. So going to continue to do this. There's a lot of work. A lot of new companies have come in. Hyperscalers are in work, has worked on this. In fact, I can tell you, chip makers, cooling equipment, electrical equipment manufacturers, all of these people have seen it, and everyone in TGG has seen this tool before it went out the door. So I can tell you a lot of eyes internally have looked at this. And essentially, we're going to start looking down the line in the future version of this about energy reuse, renewable energy, the carbon emissions, as I said, is going to be incorporated. But because of the interactivity between these factors, we had to be a little more circumspect before we issued this, all in one step. So we decided, as I said, to issue it now. Work capacities is a long-term project. There's been a tremendous amount of process internally, but we haven't released that yet. So we simply say to you, please keep your eye on TGG's work. A lot more work has been done in the last 2 years than in the last 2 years previous. Between COVID and everything else, a lot of energy has come back in the psychological term, of course. A lot of people putting a lot of work and time into this. So Green Grid, as I said, just as a play, ITI is the owner, if you will, is TGG is under ITI, which is also a well-known organization about IT equipment efficiency. And Green Grid continues to offer these metrics, white papers, etc. And if you haven't figured it out, you probably have if you found us to get to this webinar. It is thegreengrid.org, not .com. And so we now come to the question is we've talked about this metric. How do I get this metric? All right. So number one, I think I'm going to I'm going to be brave here. I'm going to show you the metric in real time. You can download this metric from the web right now, and we'll show you where. Please have your credit cards ready. That's a joke. Okay. Here's your PUE number. You can just change it to 1.5 or whatever your number is. And of course, it's going to change across the board. Now, if I click into my water usage, right, I can make it 0.5. I don't know where the wheel's going to spin, but it's going to change the numbers. Now, if I say I'm in a water stress area, and notice little pop-ups, a little bit of guidance. If I say I'm in an area like 5, which has really the highest nearly drought area, my score is not going to be a happy one. All right. We're going to see that we really have done poorly because we're using a reasonably high amount of water in an area that's in the highest stress level. If I bring this down to only a 1, my score does change as far as this goes. All right, so understand that my climate zones will impact this. If I'm in a very cold area, it's also going to be my enemy, if you will. I don't want to use the word enemy, but it's going to impact my score because it's easy to cool in that area. And finally, if I have a 0 in here, because I'm using something that does not use, the power plant is not using any water, it will also change my score from a 1.5 down to 1.46. I don't want to spend too much time in the tool, but you can certainly download this tool at the end of the program and try it, read the white paper, which brings us to our last question. How do I get it? Well, you visit the TGG library. You can see all these things. Not every one of these is free, but today, and maybe tomorrow, you can click on the white paper, white paper 93, and the scoring tool I just showed you. And other than putting in your basic information as a guess, you can not only download these, there's probably 70 or 80% of these are downloadable, and there's a whole history of papers out here going back to, when TGG was founded. So I would suggest, obviously, that, feel free to browse the library, and see what you can find that's of interest to your organization. But these are our latest metrics, and we hope that you download them and try them. That being said, I want to thank you, and back to you. I think we may have some questions from the audience. We try to address them.
Wonderful. Thank you so much, Julius, for that presentation. We'll move on to the Q&A section now. I see that we have about 3 questions in the chat and one in the Q&A function. If you have more questions, please do type them in the Q&A at the bottom of your screen, and we'll answer as many as we can in the remaining time. Okay, let's get started. So I'm just pulling up the chat here. Okay, so one of the questions disappeared. Okay, so the first question is this person was just wondering how and based on what the 20% for water has been chosen.
Yeah, this is a question I knew was going to get asked somehow. So we looked at the different systems, and again, we being the committee, as well as other people that provided input, to look at the worst case and best case for zero water usage versus, uh, maximum water usage. And we found that in through feedback, different people who have got real numbers that shared them anonymously, obviously, that we can see a 20% increase or decrease from, as if you assume mid-level, between a zero water usage, which will obviously impact those data centers that use any sort of mechanical cooling, versus a data center that uses a high amount of water, which would be the 20% worst case condition. If you're at zero, of course, that's our range. So we played with these numbers at different levels. We tried to interact to make a fair approximation. It's not an absolute number. This is the version 1. Like every other organization, such as ASHRAE, it may change over time. ASHRAE uses 90.4 now. 90.4 is climate-based, and they've changed some of the numbers since it was first issued. So we'll be looking at real-life scenarios that people may come back and say, maybe it should be more, maybe it should be less. But we had to put a line in the sand to move the tool forward. And as the committee, we went through this information amongst all the members that were participating, which was significant, and settled on 20% as the baseline figure. But it's a fair question. That was probably one of the things that we probably spent a lot of time on. Not probably, actually did. Hope that answers the question.
Okay, thanks, Julius. So the next question, do you have any plans to adjust the weighting of water usage based on its scarcity in different areas? For example, using a higher weight in regions where water is scarce and a lower weight where it is more abundant.
Well, actually, the tool does that. So to answer that question, it's already baked in the tool. The weight won't change. The rate right now is at 5%. But the answer is it's tied to the 20% range. So you can see how the 20% combined with the water factor, and let me just bring that back up since it's a fair question. All right. These are interlocked. So the climate zone still affects, your normal. If you were to pick the same number in different climate zones, it would change the numbers. But this collectively automatically works for you or against you, and I don't want to use it that way. But the water stress area, if I change it to 4, will change the impact of how much water usage. You can see it right away. So this does account for this. It's still a 20% factor because it's carried through as the sum of these numbers. So we felt that was actually accomplishing what I believe your question was asked as. So that is encompassed in the tool already.
Okay, thank you, Julius. Let's see. The next question. It seems that this tool cannot be used independently because PUE is an input. That is to say, MLC and ELC must be calculated in advance. Wrong inputs of PUE and WE will result in the wrong DCRE? That's the
Okay,
question.
so when I hear ELC and MLC, they're talking about ASHRAE 90.4, which was funny enough that I just mentioned. So in ASHRAE 90.4, it was meant to, and I don't want to speak for ASHRAE, but the intent, to the best of my understanding of 90.4, and I am aware of what's going on in 90.4. I am an ASHRAE member. I'm not on that committee, but I do follow 90.4. So PUE was not tied to the location of the cooling equipment, or rather where the cooling's being done. So that tied the acceptable number, and I say acceptable because 90.4 is a standard, which means that it's a pass-fail. So in their accounting for its location under the pass-fail theory of minimum requirement to build the building. So under 90.4, if you follow 90.4 and you employ it as a requirement, you cannot put that building up unless it meets the minimum efficiency for energy. But the energy is based only on its location. It does not include water. So it's only talking about compensating for the typical cooling number related to relation to its physical climate, and that is the MLC component adjusts and compensates for the energy use. So it's the same theory. We've just simply put this together as one component and added the water usage into this, which ASHRAE may be addressing in the near future. I can't speak for them, but nonetheless, MLC and ELC came right out 90.4. So the answer is, I don't believe that person is meant to, I don't want to say what he meant to say, but my response to that is that your PUE is as valid today as it was, and certainly the definition of it, which is exactly what we talked about in the paper, which is the IT energy versus the total energy of the building. That number is, whatever you want to call it, it is a simple number. There's only two factors to it: the total energy going into the building versus the energy that's left to the load, if you will. So that is as good today. In fact, I can go back a couple of slides here to see where we were talking about this. Just one moment. I know we have a couple of minutes. So PUE alone, coming out to whatever your IT is, if you ignore everything else in here, is as valid today as it was tomorrow or anything else. It's a facility energy effectiveness. What are my transformer losses, my wiring losses, my cooling losses, lighting, you name it, PUE is saying total input against the IT energy, respectfully.
Okay, great. Thank you, Julius. I don't see any other questions in the Q&A. Last call, if you have any questions, please type them there. In the meantime, I'll just do a quick wrap up. So, Julius, do you have anything else to add?
No, just
Okay.
thank you for
Yeah.
allowing to present, and thank you to ITI and Green Grid to help put this together, and of course do all the work. So we hope this is going to be adapted by industry, and we were looking for feedback. And while we have you on the presentation, of course, we are going to be having a workshop at DCD New York in about 2 weeks. And if you're in the New York area and you're going to Data Center Dynamics DCD New York, we'd love to have you in the workshop and ask these questions and play with the tool up front. Yes, Valerie.
Also, any of our attendees here that are Green Grid members, if you'd like to participate in what happens next with the DCRE V2, and updates to the water usage impact standalone tool, please do put forth resources and join the DCRE work group. If you're not a member of the Green Grid and would like information, please send an email to tgg-secretariat@thegreengrid.org.
I'll
Great.
throw that in the chat. Okay, thank you, Julius and Valerie. Before I wrap up with the conclusion, there is one more question. And I think this will be quick. When is part 2 estimated to be completed?
Ah, someone had asked that sometime. I knew that was coming. So the short answer is it's too early to tell. We just got this out the door in Q1. We would hope to think that this might be a by end of year, but there are a lot of complexities to this that we are trying to get, Vert2 to be complete as we can and more as accurate as we can. So Maybe we'll get some feedback from for one, but I'm saying from a time point of view, certainly if we got it out for end of year, that would be great. But maybe it's Q1. I don't want to over project, but lot of work needs to go into it.
Great. Thank you, Julius. In conclusion, thank you, Julius, so much for presenting. Thank you to the DCRE work group for all the work you've put in, and ITI as well, and everyone at TGG. And thank you to all our attendees for joining. Don't forget white paper number 93, the Data Center Resource Effectiveness Metric, and the supporting DCRE scoring calculator are currently available for free download in TGG's public library by anyone who is registered on the site. For those of you who have not already registered for a free account, you can do so by following the link that I will drop in the chat right now. Just a second.
And I will note that we don't collect a lot of personal information. It's simply a name and an email address, sort of thing, to register on the website. And also, we don't send out things to your email address. We don't even do a annual newsletter at this point. So you won't be getting spam from the Green Grid.
Exactly. Thank you for that note, Valerie. Okay, any last thoughts, Julius or Valerie, before we conclude?
Thank you for listening, and we hope that you
Yes,
download it, try it, and make use of it. We hope it's been useful to you.
absolutely. Okay, thank you so much. I will go ahead and end the webinar now.
Thanks,
Have a
everybody.
wonderful day. Thanks, everyone.
Bye.
Bye.